Before there was anything, there was a cloud of dust. From that cosmic dust, a planet was born. Our planet. But the Earth you know, a world of blue oceans and green continents, is a recent invention. In this episode of the Human Odyssey, we travel back to the very beginning to witness the 4.5 billion year life story of our world. We'll see its hellish birth, a molten sphere of rock under a sky of poison gas. We'll witness the titanic collision that created our moon and the slow, patient arrival of water that would become our oceans. We'll dive into a strange alien sea to find the first spark of life and see how these tiny organisms waged a 2 billion year war that terraformed the entire globe. We'll shiver through the greatest ice age in history when Earth became a frozen snowball drifting through space. And we'll feel the ground shake as supercontinents crash together and tear themselves apart. This is a story of impossible survival, of catastrophic destruction, and incredible creation. It's the biography of our home, a tale of fire, ice, and life's relentless will to exist. This is the story of planet Earth. Our story begins in an impossible place, a time before time, a location that wasn't a location. It begins in the dark. Not the familiar dark of a country night, but a profound, starless, silent blackness. Then, in a flash brighter than 1 trillion suns, the universe is born. For an instant, there's only light and energy. But the clock has started ticking. We must fast forward through an immense stretch of this new cosmic time, past the birth of the first stars and the formation of the first galaxies. We're looking for a very specific neighborhood, an unremarkable spiral arm of a young galaxy we will one day call the Milky Way. Here, about 4.6 billion years ago, a giant ancient star reached the end of its life. It died in a spectacular explosion, a supernova seeding the surrounding space with a rich cloud of elements, the ashes of its own heart, carbon, oxygen, iron, gold, the very stuff of which we are made. This cloud of gas and dust, called a nebula, began to swirl. Gravity, the silent, patient sculptor of the cosmos, started its work. It pulled the dust into clumps, the clumps into pebbles, the pebbles into rocks, and the rocks into boulders. At the center of this swirling disk, the pressure and temperature grew so immense that a new star ignited, our own sun. But our story isn't about the star. It's about one of the smaller children of that nebula, a humble, growing sphere of rock in the third orbit. This is the protagonist of our tale, a planet in the making. Let's call her Earth. Now, right now, she is unrecognizable. She is a monster, a seething, glowing bowl of molten rock, a planet-sized ocean of lava. Her official birth, the moment we mark as the beginning of her 4.5 billion year life, is a period of unrelenting violence. The solar system is a chaotic shooting gallery of leftover debris. The Earth is a prime target. For millions of years, she is battered by asteroids and comets, some the size of small countries. Each impact melts her surface anew, keeping the planet a hellscape of fire and magma under a thick, choking atmosphere of carbon dioxide and poison gas. There is no water, no air to breathe, no solid ground to stand on. This period is aptly named the Hadean Aeon, after the Greek underworld. It is a planet of pure chaos. And then, the single most important day in Earth's young life arrives. She's not alone in her orbit. Another young planet, about the size of Mars, has been growing nearby. Astronomers call this other world Theia. For a time, the two planets are locked in a dangerous dance. But the dance cannot last. In a moment of cosmic catastrophe, Theia slams into the young Earth. The impact is almost incomprehensibly violent. It is a blow that nearly destroys our hero. Theia is obliterated. vaporized along with a huge portion of Earth's own mantle. A colossal cloud of molten rock and gas is thrown into orbit around the wounded Earth. For a time, our planet has a ring, like Saturn, but made of fire. Gravity goes to work again. Over thousands of years, this ring of debris coalesces. It pulls itself together into a sphere, a companion, a daughter born of cataclysm, the Moon. This event is a defining moment of Earth's infancy. The Moon's gravity will forever stabilize our planet's wobble, giving us a stable climate. Its pull will create the tides, a rhythmic pulse in the oceans that may have been crucial for stirring the pot of early life. But in the immediate aftermath, the world is changed. The Earth is spinning violently, a day lasting perhaps only 6 hours. The new moon hangs in the sky, huge and menacing, 20 times closer than it is today, its scarred, molten face filling the horizon. The planet is still a ball of fire. It seems impossible that this tortured world could ever become a home. But the bombardment from space is slowing. The planet's surface begins, tentatively, to cool. A thin black crust of basalt forms, like a skin on a bowl of cooling soup. Volcanoes still rage, pumping gases from the planet's interior into the atmosphere. Among these gases is water vapor. And the comets that continue to strike the planet are not just rocks. They are dirty snowballs packed with frozen water from the outer solar system. For millions of years, it rains. Not a gentle shower, but a relentless planet-wide deluge. A downpour from a sky of steam that lasts for millennia. Water, born from the planet's fiery heart and delivered from the frozen depths of space, begins to pool in the low-lying areas of the new crust. Slowly, patiently, the first oceans are born. They are not the blue, inviting oceans we know today. They are acidic, boiling hot, and stained green by dissolved iron. The sky above is a perpetual orange smog of carbon dioxide and methane. The sun is weaker than it is today, a pale, distant ghost. And yet, something incredible is about to happen in the depths of this alien sea. The stage is set for the story's greatest mystery: life. We don't know exactly how it happened. Perhaps in the sun-drenched shallows of a volcanic island. Perhaps in the crushing, dark depths near a hydrothermal vent, where chemical-rich water spewed from the planet's core. But somehow, somewhere, in that primordial soup, a collection of simple molecules did something they had no business doing. They began to work together. They built a protective wall around themselves, a membrane. They learned to store information in a long, twisting molecule called DNA. And most miraculously of all, they learned to make copies of themselves. The first life on Earth was here. It was nothing impressive to look at, just a single cell, a microscopic bubble of chemistry. For 1 billion years, this is all that life is. A silent, invisible film of bacteria in the iron-rich oceans. These tiny organisms, our oldest ancestors, are the unsung heroes of this story. They are about to perform the single greatest act of planetary engineering in Earth's history. One group of these bacteria, called cyanobacteria, develops a new trick. It's a revolutionary way to make a living. They learn to harness the energy of the faint, young sun. They learn the magic of photosynthesis. They breathe in carbon dioxide and water, and they use sunlight to turn it into sugar, their food. It is an incredibly successful strategy. They multiply, spreading across the surface of the oceans, forming vast, slimy mats. But this new process has a byproduct, a waste product. A poison gas that is slightly reactive and toxic to almost all other forms of life on the planet at the time. This poison is oxygen. For hundreds of millions of years, the oxygen they produce is immediately captured by the iron of the oceans. which rusts and settles to the seafloor, forming vast deposits of banded iron that we mine today. The planet is literally rusting. But eventually, all the iron in the oceans is used up. The oxygen has nowhere else to go, so it begins to bubble out of the water and into the atmosphere. What follows is a global catastrophe. The Great Oxygenation Event is a slow-motion apocalypse. The air, once thick with methane, is now being filled with corrosive oxygen. For the anaerobic life that had dominated the planet for over 1 billion years, it is a holocaust. Entire ecosystems are wiped out. The planet is facing its first great extinction event, and the culprit is life itself. But life is resilient. Some bacteria retreat into the mud away from the poison. Others evolve new ways to not only survive in the presence of oxygen, but to use its powerful chemical energy. This new oxygen-breathing metabolism is a supercharger. It provides far more energy than the old ways. It is the key that will unlock a new level of complexity. Life has survived its own revolution. The planet itself is transformed. The methane in the atmosphere is destroyed by the oxygen. Methane is a powerful greenhouse gas, and without it, the planet's thermostat plummets. The Earth grows cold, very cold. Our hero enters her long and difficult middle age. For the next billion years, a period sometimes called the boring billion, not so much seems to happen on the surface. But deep within the planet, the great engine of geology is at work. The Earth's crust is not a single solid shell. It is broken into giant pieces like the cracked shell of an egg. These are the tectonic plates. Floating on the semi-molten mantle beneath, these plates are in constant slow-motion motion. They drift at about the speed your fingernails grow. Now, this is the theory of plate tectonics, the grand unifying story of geology. This continental drift is the planet's pulse. The plates crash into each other, throwing up massive mountain ranges like the Himalayas. They pull apart, creating vast rift valleys and new oceans. They slide past each other, causing earthquakes. This constant recycling of the crust is vital. It regulates the planet's temperature over geological timescales and brings essential minerals to the surface. During this long Middle Age, the continents are on the move. They clump together to form a vast supercontinent called Rodinia. For a time, most of the world's landmass is a single, desolate expanse. And then, the planet freezes. We're not sure of the exact cause, but a perfect storm of geological and biological factors plunges the Earth into the most profound ice age it has ever known. It is called Snowball Earth. From the poles to the equator, the ocean freezes over. The white ice reflects the sun's light back into space, making the planet even colder. Earth becomes a glistening, white snowball, its surface temperature averaging minus 50 degrees Celsius. The great experiment of life is on the brink of failure. How does it survive? For millions of years, life clings on, perhaps in slushy patches of open ocean near the equator, or in the warm, sunlit cracks of the ice itself, or clustered around the life-giving heat of volcanic vents on the seafloor. The planet's own geology is its savior. Even on a frozen world, the volcanoes are not silenced. For millions of years, they continue to pump carbon dioxide into the atmosphere. With the oceans covered in ice, this CO2 cannot be absorbed. It builds up and up and up until it creates a super greenhouse effect. The thermostat is finally turned back on. The ice begins to melt, slowly at first, and then in a catastrophic runaway thaw. The snowball Earth is over. This deep freeze and sudden thaw seems to have been a wake-up call for life. In the aftermath, in the warm, nutrient-rich seas, something spectacular happens. It is as if a silent black and white film suddenly explodes into vibrant color and sound. This is the Cambrian explosion. For 3 billion years, life had been simple, microscopic. Now, in a geological blink of an eye, it becomes big, complex, and weird. The oceans are suddenly filled with a bizarre menagerie of creatures. Animals with 5 eyes, creatures that look like walking spikes, the first predators, the first prey. This is the invention of the animal kingdom as we know it. Almost every major body plan that exists today is established in this frenzy of evolution. Life is no longer content with the oceans. The land, for 4 billion years our barren wasteland of rock and dust, beckons. First, simple green algae make the journey, clinging to the damp edges of the continents. They evolve into the first plants. They create a new substance the world has never seen before: soil. They pump more and more oxygen into the air. Slowly, they transform the hostile alien landscape into a green world. Then the animals follow. First, creatures like scorpions and millipedes, ancestors of modern insects, venture out of the water. Then a fish with sturdy, lobe-like fins does something extraordinary. It hauls itself onto the shore. This creature is our ancestor. Its fins will evolve into legs, its swim bladder into lungs. The conquest of the land has begun. The continents, meanwhile, continue their slow dance. They are converging again, pulling together into the most famous supercontinent of all, Pangaea, a single vast landmass stretching from pole to pole, surrounded by a single global ocean. The world is now a lush, tropical paradise. Great forests of ferns and primitive trees cover the land, inhabited by giant amphibians and strange mammal-like reptiles. But our planet is a dangerous character. Her biography is punctuated by periods of catastrophic violence. And the greatest of them all is about to strike. We call it the Great Dying. At the end of the Permian period, about 252 million years ago, a series of volcanic eruptions of an unimaginable scale begin in what is now Siberia. For 1 million years, lava pours out, covering an area larger than Western Europe. The eruptions release colossal amounts of carbon dioxide and other gases, triggering runaway global warming. The oceans become acidic and lose their oxygen. The result is the closest life has ever come to being completely extinguished. It is a near-total planetary sterilization. As many as 95% of all species in the oceans and 70% of all species on land are wiped out. Life's intricate tapestry, woven over billions of years, is almost completely unraveled. It takes the planet 10 million years to recover. But the survivors of this apocalypse inherit a nearly empty world, full of opportunity. And one group of survivors is poised to take over. They are the dinosaurs. For the next 150 million years, the Mesozoic era, they are the undisputed masters of the Earth. From the fearsome Tyrannosaurus rex to the gentle giant Brachiosaurus, they dominate every continent. Pangaea begins to break apart. The Atlantic Ocean is born, and the continents start their slow drift towards the position we know today. The world is warm, green, and ruled by giants. Now, while the dinosaurs rule the day, another group of animals is biding its time, living in the shadows. They are small, furry, and nocturnal. They are the first mammals, our ancestors. For millions of years, they live at the feet of the dinosaurs, a minor part of the planet's drama. And then, 66 million years ago, the sky falls. A rock 6 miles wide, an asteroid from the depths of space, is on a collision course with Earth. It strikes the planet in the Gulf of Mexico with the force of 10 billion atomic bombs. The impact creates a crater over 100 miles wide and sends a blast wave of unimaginable heat and force across the continent. It triggers global earthquakes, volcanic eruptions, and colossal tsunamis. A cloud of superheated dust and ash is thrown into the atmosphere, enveloping the entire planet in darkness. The sun is blotted out. Photosynthesis stops. The plants die. The herbivores that eat them starve. The carnivores that eat them follow. The long, glorious reign of the dinosaurs comes to an abrupt and fiery end. But the story isn't over. Catastrophe for one group is opportunity for another. The small burrowing mammals that survived the impact emerge into a changed world, an empty world. With their great rivals gone, they explode in diversity, evolving into the vast array of mammals we see today, from whales in the sea to bats in the air, and on the plains of Africa, a clever, upright ape. The Cenozoic era, our era, is the age of mammals. The continents continue to drift, India slamming into Asia to create the Himalayas. The climate cools, plunging the planet into a series of more recent ice ages. Great sheets of ice advance and retreat across the northern continents, carving out valleys and creating the landscapes we now call home. And in Africa, that upright ape is getting smarter. It learns to use tools. It learns to control fire. It develops a new, powerful tool for communication, language. It begins to ask questions. It looks up at the moon, the daughter of that ancient cataclysm, and it wonders. This new creature, Homo sapiens, spreads out of Africa across the continents to every corner of the planet. In the last few seconds of our planet's long day, we have arrived. Our story, the 4.5 billion year biography of our planet, has brought us here, to this moment. We are the children of this planet's fire and ice. The iron in our blood was forged in the heart of a dying star. The water in our cell was delivered by comets. The oxygen we breathe was created by ancient bacteria. The carbon in our DNA was cycled through volcanoes and oceans and the bodies of long extinct creatures. Our very form was shaped by the great extinctions and the slow dance of the continents. We are, in the most literal sense, made of Earth. We are her consciousness, the part of her story that can look back and try to understand the whole. We are living in a brief, warm interlude in an ongoing cycle of ice ages on a thin, fragile crust that floats on a sea of fire. The story of Earth is not over. A new chapter is being written, one where a single species has become a geological force in its own right, able to change the climate and the chemistry of the planet. We are the first characters in this story who are aware that we are part of it. What we do next, the kind of ancestor we choose to be, will determine the course of this biography for millennia to come. The planet has survived far worse than us. It has been a ball of fire, a snowball of ice. It has been poisoned and battered. The question is not whether the Earth will survive. The question is, will we? And with that, my friends, we come to the end of our episode. I hope you enjoy it. The story of Earth from our Human Odyssey series. Thank you very much for listening, and don't forget to come back for other stories from the Human Odyssey series. I'll see you next time.